Hey guys! So today we're going to be talking about matrix operations. Before we talk about the operations, let's talk about what a matrix is. So a matrix is a rectangular array of variables or constants in horizontal rows and vertical columns usually enclosed in brackets. Okay, so each value in the matrix is called an element. And a matrix is usually named using an uppercase letter. So let's do an example of a matrix. So here we have matrix A, a bracket, and then we're going to do 8, -1, 7, -2, 3, -8, 5, -3, 1, and 6, 6, 4. So here's an example of a matrix. You'll see we've got 3 rows. So 1, 2, 3. Then we have 4 columns. Okay. An element, so let's look at the element -1. So element -1 is in row 2, right? So 1, 2, and column 1. So this can be depicted by A 2, 1. So this is just telling us that we've got row 2, column 1. So 8 or -8 over here, for example, would be A sub 3 because it's in the 3rd row, and 2 for 2nd column. Alright, so let's do an example. Oh wait, just kidding. I have to talk about the dimensions. So matrices, or a matrix, can be described by its dimensions. A matrix with m rows and n columns is an m by n matrix. So the matrix we did above had 3 rows and 4 columns, so it's a 3 by 4 matrix. Alright, let's do an example. Actually, let's do a U-try. I feel like this is enough for you guys to be able to do it on your own. So given this matrix, A equals 4, 9, negative 18, negative 2, 11, 3. So, two things. A, state the dimensions. B, find the value of the element that'll be written as A sub 13. I'll pause the video so you guys can complete this. So this is a 2 by 3 matrix because we've got 2 rows and 3 columns. And the value of A13, well, the first number written is the row and the second number is the column, so that is going to be row 1, column 3, so negative 18. Alright, let's move on now to adding and subtracting. So you can only add and subtract matrices if they have the same dimensions. So you can only add or subtract matrices if they have the same dimensions. So, for example, if you have matrix A plus matrix B, let's have A, B, we'll generalize it, so A, B, C, D, plus matrix B, which is going to be E, F, G, H, and that's going to be equivalent to A plus E, B plus F, C plus G, and D plus H. So you just add the corresponding elements together, and subtraction is going to work the exact same way. So if it were A minus B, we're going to do A minus E, B minus F, C minus G, and D minus H. And we're still going to have a 2 by 2 matrix. So why don't we do a U-try based on this rule? So if matrix A equals 8, 3, negative 5, 14, and matrix B equals 12, negative 7, 6, and negative 23, and then let's do matrix C, have that be 2, 9. So given all that information, I'd like you to do 3 problems. A plus B B minus A and B minus C. Right. Can I zoom out? There we go. Alright, there's all of them. Let's pause the video. Alright, so for the first one, A plus B, hopefully you showed your work. So that's just going to be literally showing matrix A plus matrix B. But then you can just add them together. So 8 plus 12, 20, 3 plus negative 7, negative 4, negative 5 plus 6, 1, 14 minus 23, negative 9. For matrix B minus A, you end up with a 2 by 2 matrix, 4, negative 10, 11, negative 37. And then for B minus C, this is not possible because we have a 2 by 2 matrix and a 2 by 1 matrix. And remember, they have to be the same dimensions. So you can you can add and subtract like 3 by 3s, 5 by 5, 6 by 6, but they have to be the same dimensions. 3 by 2, it doesn't matter. They both just have to be the same dimensions. Alright, finally, we're going to talk about scalar multiplication real quick. So scalar multiplication is very easy and intuitive. We're just going to do an example, and we're not even going to do a U-try. So if I have negative 4 on the outside times the matrix C 2, negative 9, 7, 3, negative 11, 4, you actually can just multiply each one of these by the negative 4. So you're going to multiply the scalar by each of the elements. And we're still going to end with a 3 by 2 matrix. So we're going to do negative 4 times 2, negative 4 times negative 9, negative 4 times 7, negative 4 times 3, negative 4 times negative 11, and negative 4 times 4. And that's it. So whatever your matrix size originally was, your new matrix C is going to have the same dimensions.